Okay, now in this question, on the left side, you can see we have a square. This is whole square of sine plus sec, and this is whole square of cos plus cosec. So let's start with the squaring. So we are solving the left hand side. So first of all, we have to take square of sine plus cos. So it will be sine square A plus sec square A plus twice sine into sec. Now moving on to the second square, we have cos square plus cosec square plus twice cos into cosec. So in the first step, we have taken square of these two. Now in second step, we will do the grouping. So I will do grouping of sine square with cos square. See, I will do grouping of sine square with cos square. One grouping. Second grouping I will do of twice sine sec and twice cos cosec. This is the second grouping. 2 sine sec plus 2 cos into cosec. And the last grouping I will take of sec square and cosec square. So I have sec square plus cosec square. So first step, I open the two brackets. In the second step, we have done the grouping. Now the first grouping, sine square plus cos square, will give us 1. Now in the second grouping, first of all I will take 2 common. Now here I am left with sine into sec. So I can write it this way, sine upon, now sec will be written as upon cos A. Here I have taken 2 common, so I am left with cos. This cosec as a denominator will be written as sine. Now moving on to the third group. Third group, sec square will be written as cos square and cosec square will be written as 1 upon sine square, like this. 1 plus twice. Now here I will take the LCM. LCM is cos into sine. So the first term will give me sine into sine, sine square. Sine and sine will cancel. This will give you cos square. Here LCM will be cos square into sine square. So this will give me sine square plus cos square. Now the next step, here I can use the identity. So sine square cos square will give us 1 and we are left with cos. And similarly in this one, sine square plus cos square will give us 1. So it's cos square into sine square. So this will become, now here we will take the reciprocal. So cos and sine on reciprocal will give us sec into cosec. Here also we will take the reciprocal. So cos square will give us sec square into cosec square. Okay, now see, first term is 1, so 1 can be written as square of 1. Here we can write 2 into 1 into sec A cosec A, and this can be written as sec A cosec A whole square. Okay, now you see the result. If I consider 1 as A, if I consider 1 as A, So I can write this is a square. Then I have 2 into 1 I have considered as a, and if I considered sec into cosec as b, so this is 2ab, and the last term a, this is b, sec a into cosec a, so b square. So this expression I am getting in the form a square plus 2ab plus b square. So this will give you a plus b whole square. So that means applying this condition, I can write the above expression as a plus b whole square. Here a is 1, b is sec a cosec a, whole square. So this is equal to right side. This was required on the right hand side. Okay, now in this question on the left side we have cot upon cosec plus 1 plus cosec plus 1 upon cot, and we have to prove this result is equal to 2 sec a. Okay, so let's start with the left hand side. So on the left hand side what we can do, we can take LCM here. So LCM will be cosec a plus 1 into cot a. So we have taken the LCM here. So left side this will be the LCM. So cosec plus 1 will reduce cosec plus 1. So we are left with cot. So this will be multiplied in the numerator place. So you will get cot square. In the second term cot will reduce cot. So you are left with cosec plus 1. It will be multiplied in the numerator place. So you will be getting cosec plus 1 whole square. Okay, now let's square these terms. So first one is cot square a. Now you will open this bracket with the formula a plus b whole square. So that will give you cosec square plus 1 plus twice cosec a. See, we have used the formula a plus b whole square here. So we are getting this result in the numerator place. So in the denominator place it is cosec a plus 1 into cot a. Okay, now see, in the numerator place we will take the grouping of these two. So cot square will be grouped with 1 cot square, and in the second group we will take these two. So we will be getting like this, cosec square plus twice cosec, like this. Upon cosec plus 1 into cot a. Now this 1 plus cot square, this can be replaced with cosec square. So we are getting cosec square plus cosec square plus twice cosec a upon So here we have used a trigonometrical identity. 1 plus cot square is replaced with cosec square. Now in the numerator place, cosec square plus cosec square will become twice of cosec square. and then we are left with twice cosec A, and in the denominator place it will remain as it is, cosec plus 1 into cot A. See, it will be like this. Okay, now in the numerator place you can take twice cosec common, so we have taken twice cosec common, so we are left with cosec plus 1. See, we have taken twice cosec common, denominator remains as it is, cosec plus 1 into cot A. Now you can see in the numerator place and the denominator place, this cosec plus 1 will cancel out, so you are left with twice cosec upon cot. Okay, now convert these cosec and cot into sine and cos, so this will be twice. Now cosec when written in the reciprocal form will be 1 upon sine A. This cot when taken in the numerator place will be written as tan A, twice 1 upon sine. This tan will be written as sine upon cos, so here this will cancel out, so you are left with 2 upon cos. So this cos can be written as sec, so this result is twice sec A, that is equal to right hand side. So this was required. Hope this is clear to you now. So this is how you can solve this question. Now see, in this question, this is our left hand side, so we are starting with the left hand side. So on the left hand side, this is, now on the left hand side we will take LCM, so LCM will be sine A plus cos A plus 1 into sine A plus cos A minus 1. So this will be our LCM part. Now in the first term, denominator is cos plus this sine plus cos plus 1. This will reduce this part, so we are left with this. It will be multiplied in the numerator part. So in the numerator part we are getting sine plus cos minus 1. Now in this one, denominator sine plus cos minus 1 will reduce this, so you are left with sine plus cos plus 1. This will be multiplied in the numerator part. So now we will open the bracket here. Sine A plus cos A minus 1. You open this bracket, you will be getting sine A plus cos A plus 1. In the denominator place, now see how I will multiply the two terms. See, method of multiplying these two. What you will do, you will consider this sine plus cos as A, this plus 1 as B. Again in this one, sine plus cos to be considered as A, and this 1 is to be considered as B. So in the denominator place you are getting product of A plus B with A minus B. So product of a plus b with a minus b will give you a square. So a is sine plus cos. So a square minus b square. See? Okay. Now in the numerator place, this plus minus will cancel out. So you are left with sine plus cos, so that is 2 times sine plus cos. We are getting sine plus cos, then again sine plus cos, so you can say you are getting twice sine plus cos. Now in the denominator place, let's open the bracket. So sine a plus cos a whole square will give you sine square plus cos square plus twice sine cos, and then you have got minus 1. The square of 1 will give you minus 1. Now in the denominator place you can use the identity. So sine square plus cos square will be replaced by 1. So we will write 1 minus 1. Now you can see in the denominator place plus 1 minus 1 will cancel out. So this will give you twice sine a plus cos a whole upon twice sine a cos a. Now this 2 will also cancel out. Now in the next step, what we are going to do, we are going to do the partial fraction over here. Sine a with the denominator, sine a cos a, sine a cos a. Then in this one again cos a with the denominator, you will write them separately. See, this sine into cos is denominator for both. Now see, here sine will be cancelled out, cos will be cancelled out, so you are left with 1 upon cos plus 1 upon sine. 1 upon cos is sec a, 1 upon sine is cosec a. So this is what was required on the right hand side. See? Hope this is clear to you.